Everybody. Thank you for joining in and being a part of this evening. This is Shruti Khurana on behalf of TCS iON. I welcome you all to this webinar where we will talk about free masterclass on data analytics. Today we are diving into the exciting world of data analytics. How data is transforming the way we understand solve real world problems. We will explore how data analytics enables business to make informed decisions, optimize processes, and uncover valuable insights from vast amount of data. From understanding the fundamental of data collection and cleaning to advanced techniques in analyzing trends and patterns, this session will give you a glimpse of fascinating world of data analytics. Whether you are new to the field or looking to sharpen your skills, this masterclass will provide you with practical knowledge that will prepare you for a career in this data driven world. I'm thrilled to introduce our expert speaker for today. Please give a warm welcome to Dr. Saurabh Srivastav. Welcome, sir. Let me
Hi,
give you a
Shruti.
let me give you a quick introduction of the sir. Dr. Saurabh Srivastav is an assistant professor in the Department of Computer Science and Engineering at IIT ISM Dhanbad. He has over 7 years of experience in industry and academia with roles spanning around across development, planning, and architecture of IT solutions. He has worked in organizations with varying profiles, including the prestigious Space Agency of India, ISRO. His area of expertise includes software architecture and engineer as well as AI intensive system. He holds a doctorate and master's degree in engineering from the Department of CSE IIT Kanpur. During his master's, he was the top ranker in his department, for which he received the Academic Excellence Award from the institute. He is currently serving as the functional positions of faculty in charge, automation of the institute, and co-faculty in charge and data and software technology club under the Narek Vashish Center for Tinkering and Innovation. He is also a member of the executive committee of Techsman Foundation, a technology innovation hub set up by the Department of Science and Technology, Government of India. It's an honor and pleasure to have you in our session today. Once again, a very warm welcome, Dr. Saurabh. So now, Saurabh sir, before we dive deeper into this exciting masterclass, could you briefly explain what data analytics is and why it's so crucial in today's business and technology landscape?
Okay, so frankly speaking, I will answer this right in the first slide itself. But just to give you an overview, you have to understand today everything that we work, right? Everything we do right from, let us say, day one to day end in any business process. You need data at almost every step. Even in a manufacturing company where probably you might feel that, okay, this is a place where there are mechanical engineers, there are electrical engineers, there are people who are hardcore, technicians. Even there, you would see that a lot of data gets collected, right? And this data can be, for example, related to a machine's health. It could be related to how many units of production are we actually doing per day. And all these things essentially feed into some kind of a pipeline, and the people at different levels of the administration, they get access to this data and then they try to make some kind of a decision, right? So all this, you understand that this is somehow data driven, but the point is data is not always available in a form that is easily ingestible, right? And there has to be a lot of things that you have to perform a number of operations over the data so that it becomes more relevant. So I hope, Shruti, that would be a nice start to the session, and we can now, if you allow me, I can share my screen.
Absolutely, absolutely, sir. It is a really nice start that we have to actually perform a various operations. From here, we can start very nicely. So I'll
Okay.
hand over a session to you. Please begin your masterclass.
Thank you, Shruti. Okay, so let's start. There are two modes in which a typical teacher works. Okay, one is the mode of an administrator, the mode of a researcher, for example, and then there is the mode of a teacher, right? So basically, up until now, you were probably looking at a guy who's just sitting on a chair, talking to people in a sweet way, and then somehow finding that his or her way within a whole room where a lot of people. I mean, today all these are rooms, right? I mean, we are now in the virtual world, so maybe there are 500 people or so in this particular room. So let us start, and I'll start with a very basic quote, right? This quote is by a mathematician called Clive Humble. So he said that data is the new oil, right? You understand what this really means, right? Oil is something which has driven economies for a very wide. Am I not audible?
No, sir, you are audible.
Okay, so I hope that there are some of you who are having issues with your
System,
speakers,
right,
right?
right,
Just yeah, just
right.
just enhance the volume somehow, right? Uh, how to connect to a voice. Yes. Okay, thanks a lot. So I understand. It's perfectly fine. I keep seeing all these kind of comments every time. That COVID period has actually taught faculty members also a lot, right? We had to learn skills which were not really relevant in the typical pre-COVID era, right? So let us start. So I was talking about data, right? And the reason that data is considered as the new oil is because we have seen the pre-IT revolution era, where the countries that had oil, they were the ones that were making a lot of money, right? And you understand why, because oil is something that essentially drives the economy, right? So when we say data is the new oil, it like clearly explains why it is the new oil, right? It is something that can drive whole economies. But then again, there is a major issue with it, that if data is really oil, it is the oil of modern day, then crude data should probably be only as useful as crude oil, right? I mean, if you're talking about crude oil, you understand crude oil is of not much importance to us, right? That oil must be somehow refined, it must be brought into a form that becomes useful for us, right? So, for example, we take up this crude oil from different countries. I'm pretty sure you would know all this politics going on about how India charges so much money on petrol and diesel. And then, every time the government comes up with some kind of an excuse saying that, see, it's not really the crude oil that we produce, but, we take up this crude oil, we then process it, and then we send it over on our different supply chains. So they say that it is this amount of processing that actually makes it quite difficult to sell it cheap. So the same thing is true with data as well. Data is everywhere, as Shruti said at the start of the session. Um, Data you can find pretty much everywhere, even machines today, right? And I'm not talking about computers. I'm talking about machines that are involved in some kind of production activity. Even these machines also produce data, but not all the data, as I said, is going to be something that can directly be consumed by us in order to make decisions, right? And in fact, one of the things that I would like to just talk about is how we, the computer scientists, we are so creative with naming, right? If you have a look at all the technology and all the terminologies that we use around, right? We have a habit of picking up terms, of picking up, concepts from all other fields of science, right? So even the whole concept of a neural network comes from brain, right? It comes from biology. So we borrow terms from nature, geography, construction, everywhere, right? And in fact, this is something that I just was thinking about yesterday, right? We mine data in a cloud and then pass it through a pipeline, store it in a warehouse. You understand all these terms: cloud, mine, pipeline, warehouse. These are not the terms that are coming from computer science. They have come from different fields, and we are just using them here, right? So now the idea is, what exactly is this whole concept of mining data, right? So data mining, as I was just trying to motivate you, is basically the process of discovering patterns, trends, and insights from large data sets, right? This is essentially what data mining essentially tells you, right? And this is a very old definition. If you see, this definition dates back to 1996, right? So people realized the importance of data as long as, let us say, as back as 1996. So then what exactly is this whole mining process going to do? One way to look at it is that, assume that you have some kind of a mine, right? I'm pretty sure you understand what a mine is. I am currently talking from Dhanbad. Dhanbad is known to be the center of India's coal, right? We are living in a city which is kind of supplying most of the electricity that is being used across the country. But coal does not come easily, right? You have to mine the coal. You have to go inside the mines, then there are a number of what can I say? There are a number of large dumpers that you have to bring with you. You have to load the coal in those large trucks or whatever you call them, right? I think dumper is the right word. And then you take it out. You have to process it. Not all the coal can be used in a typical substation, right? In a typical power station, right? So you have to go through a number of operations in order to make coal useful. You can now understand that in some ways, data mining is basically doing the same thing. It is essentially a kind of a mining process, but now we are going to do that over raw data, right? And essentially, what you get at the end are these valuable nuggets of information, right? So, one thing that you would understand already is that this term is essentially coming from the mining industry, from the geology. We have a geology department here, by the way, right? And the geology department guys are the ones who talk about all these different types of rocks. They talk about their properties. So essentially, what we are doing here now, as part of this data mining activity, is that we are going to see different types of rocks, not rocks. We are talking about data, right? So what replaces rocks is data. So what can be the different type of data that you would see? Data can be present in the form of text. For example, I might give you a PDF. There could be some data that is written in a PDF. It could be images, for example, right? These are images that you might click somewhere or you might collect through the internet. It could be video. It could be audio. Data can come in different shapes and sizes, right? And the kind of techniques that you are going to apply in order to find those nuggets out of it, right? This is going to be dependent on the kind of data you have and what exactly do you expect, right? So we were talking about what exactly is data mining. I gave a very simple introduction to you. I said that one way to look at data mining is that if you are in the mining industry, you have to figure out what is the best way to mine some particular element. Or if you are, let us say, working in the oil industry, you have to have that kind of skills which are required in order to drill oil and then somehow refine it to make it more useful, right? So the same thing can actually be seen in the case of computer science as well. That if you are going to work in the field of data science, overall, you are supposed to have some kind of skills. And these skills are going to help you in doing what essentially is considered as data mining. And the reason it all matters is because pretty much like mineral or oil, for this whole data to make any sense to you, you have to have some kind of operations over it, right? So for example, if you want to use this so-called raw data into actionable knowledge, right? So what do I mean by actionable knowledge? I gave an example of these machines that produce a lot of data. This data is also considered as telemetry data, right? So telemetry is basically a kind of data where, in fact, telemetry is a very, very common term. It is not only used for machines in a production environment, right? Even satellites. I used to work in ISRO, and one of the things that we used to do there was that whenever you receive data from a particular satellite, this data also includes the data about the satellite itself. You know, maybe the satellite is trying to do something for us. For example, it might be taking pictures, it might be used as a communication device in the space, but at the same time, these satellites also send us their own telemetry data. But all this data is raw, right? In fact, in many cases, this is nothing more than a stream of bytes. And we have to figure out what part of this whole stream essentially corresponds to what data, right? So essentially, if we want to understand if this satellite is going to develop some kind of a problem in near future, unless you kind of mine the data that you are getting, right? Unless you kind of process that data. And when I say processing, processing could be extremely simple. For example, you just need to figure out what is the min and the max of a particular column within, let us say, an Excel sheet. Or it could be as complicated as visualizing it in a two-dimensional or n-dimensional plane and then seeing how exactly is the data getting scattered in the whole space, right? It depends what kind of action you want to take, but overall, the kind of skills you require, right? It might, you can probably say that this is what these skills would look like. This is what the typical data would look like. I mean, I'm just showing you a particular example of a data set that I saw on Kaggle, right? So typically, this is how raw data looks like. You can see what exactly is happening. There are there is some text. For example, there is the name of a city. This looks pretty much like a date. Frankly speaking, right from the outset, I don't even know what it looks like. But because if I see it here, it could be, let's say, a time. And then there are certain things written here, right? PM 2.5, PM 10, NO, NO2, NOx. So essentially, these are some kind of gases, some kind of pollutants that are present in the air, right? And if you go to Kaggle and you try to find out a data set which you are interested in, let us say, if you are an environmentalist and you are trying to build some application that is going to warn people about the doom that is coming up our way in the next decade or so, and you want some actual real data, if you go and try to find out data, this is exactly how actual data looks like, right? In fact, in many cases, you might not even understand what this really means. If you have a background in computer science, you might have already guessed what it looks like, right? Because at the top, it says station ID, right? So if you have done a basic course in databases, you would know that this is some kind of a primary key or some kind of a key, I would say, not just really a primary key, because here there are multiple instances of that, but it might be a primary key in some other particular table. For example, this could be that table where from where this primary key is coming up, and what you are seeing here is kind of a foreign key. And what exactly all these things mean, primary key, foreign key? Essentially, many a times when you receive data, the data cannot just be merged into one basic file, right? It might make it extremely large to share. So what people do is they try to optimize the data storage, right? And this is one particular example that the data has been split across three different files. And if you actually want to make sense out of this data, unless you have all these three files together, and then you start stitching the data from one file with let us say data in another file, and then maybe in a third file, unless you do this stitching properly, you won't even be able to understand what this data really talks about, right? So one of the major problems that you will face in the real world is that many a time data would be exactly in this form, whatever you are seeing right now, right? In fact, one of the major problem really is if you want to use this particular type of data, right, you are going to need certain kind of skills, right? So what are those skills going to be? This whole field of data mining can be seen as a melting point of statistics, machine learning, and database. In fact, I had actually asked ChatGPT about a joke on computer science and mathematics. In fact, I just skipped over that joke because I thought we might not have enough time towards the end for the demo. But that joke that ChatGPT came up with was that essentially computer science is a field where people work on things which mathematicians have figured out long back. Right? This is the kind of a burn that ChatGPT gave me. But then you can understand why that burn came up, right? Because whenever we talk about computer science, there is going to be some mathematics involved. Even in the case of data mining, we are going to do a lot of things like machine learning. We'll have a lot of databases, and you'll have to figure out efficient ways of querying the database. But in most cases, it all boils down to statistics, right? In many cases, the beginning of any kind of data mining pipeline is basically statistics, right? You start off by analyzing the data, you figure out what does this data actually looks like, and then over a period of time, you figure out what kind of tasks can be performed over this data, right? So ChatGPT wasn't really that wrong in the insult when it said that we the computer scientists are just a kind of I remember a particular saying from a particular sitcom called The Big Bang Theory, right? So there is a character in The Big Bang Theory called Sheldon Cooper, and one of his major uh, problems with engineering is that he says that engineering is essentially a slow brother of physics, right? We are not really talking about physics here, but I can essentially correlate it back to mathematics because I am a computer science guy. So in most cases, what we do in computer science is just a kind of an extension of mathematics. So whatever you would do on a pen and paper in the field of mathematics. Essentially, we computer scientists have written code for that. There are libraries for it today, and you don't actually have to learn so much of mathematics in order to do this, right? So let us go through some of the major skills that you develop as a part of a course in data science, as a part of a course in AI, or as I said, whenever I said you need some kind of tools in order to do this mining, there are certain tasks that you perform, right? So one of the most basic things that we do is what is known as classification. And I'm pretty sure if you have had any idea about machine learning, probably the first thing you would have tried out in any of these so-called machine learning tutorials is what is known as classification. So classification is nothing but, let us say, assigning a particular category. If I give you certain elements and then I say, okay, this element belongs to category A, this element belongs to category B, and this element belongs to category C, and then I give you a fourth element and I ask you, okay, can you tell me out of these A, B, C, which particular category does this element belong to? It's a very simple, straightforward machine learning application, but it also has its own importance in the field of data mining. So for example, in the case of that data set that I showed you, which was essentially having these pollutants in the air, one thing that we can do as part of our data mining pipeline is that if you give me some basic information like what is the PM 2.5 value, what is the PM 10 value for a particular city at a particular day, I can probably say whether the air quality is good, moderate, or poor. So this is an example of classification. The other things that we can do include regression. So uh, you can call regression to be, let us say, the first cousin of classification. Most of the things that we do in classification can also be done in regression with some minor modifications or vice versa. But here, instead of predicting a particular class, we predict a particular value, right? So for example, a good example for this would be if I give you the AQI, the air quality index for a particular city on, let us say, today or yesterday, can I somehow predict what will be the AQI for the next day or even the next hour, right? This is essentially going to be a value. This is not going to be a class. It is going to be a value that I can predict. So regression essentially involves predicting a value instead of a class. And then this is something that might be new for you. Even if you have been a machine learning enthusiast for a very long time, this is something that you might have ignored till now, right? You might feel that visualization and exploration of data is something that is not really important, right? In fact, you probably are not really mistaken. I have seen students today, what they do is they just pick up some data set, then they read about some of the basic classification or regression models that are there. If nothing else, they'll simply jump to neural networks. They'll apply the classification or regression algorithm over it, and then they'll finally come up with a solution, with a result, right? They often miss that one of the major steps towards any kind of machine learning or any kind of AI related problem solving is that you have to visualize the data and figure out what exactly is right for this type of data, right? Many a times you might pick up a model just by looking at what this data distribution looks like, right? I mean, if the data distribution is just a bell curve, why do we even need something as complex as neural network, right? So in many cases, this visualization essentially means plotting, right? You try to put these points which are there as part of your data set on some kind of a plot. These could be box plots, histograms, line plots, right? But the idea is if you are able to do this efficiently, visualization and exploration can be, let us say, the first step towards building something more complex to do something that is going to be more involved. And then there is one particular thing which is of very high importance for not just the data mining community, but essentially anyone who has done any kind of AI or machine learning task. And this is known as feature engineering, right? Feature engineering can be considered as a way in which you either create new features or you basically delete the existing features. Yes, in many cases, there are features which are better off deleted rather than being used for any kind of processing because these features might have a lot of noise. They might not really contribute towards what you are trying to do. So feature engineering is a field of this whole AI and DS realm, where we analyze the data and we try to figure out if there is any other way in which we can make this data more enriched. For example, you can add some more evaluated columns to this whole data set. And then these so-called evaluated columns can then be fed to a classification or regression algorithm, right? So let us, and then of course there are going to be many more which you will study as part of this course. But let us essentially start doing some mining. I had prepared some code. I don't know. I saw some of you are not able to access that particular link. But I hope at least some of you were able to do that because there is essentially going to be some code that I will execute in front of you, and I'm just continuing with that those comparisons that I had in the beginning with the mining industry. So if we want to do some mining, right, we need a tool set in order to do this, and the poor man's tool set for data mining is Python. I mean, of course, I'm calling it the poor man's tool set because there are other tools which, for example, like Power BI, but then you understand that there is a money aspect involved with it, right? So in this case, we are just essentially trying to use Python. Python is omnipresent. You can download it for almost all operating systems that I know of. You can even do that on a mobile phone. So Python is kind of omnipresent, and if you plan to have a career in the field of AI and DS, I guess one thing that you need to learn is Python, right? Once you learn Python, you would understand that how even a small piece of code in Python can do wonders for you, right? And in many cases, you don't even need to understand that what exactly is does this function call do. All you need to do is just use the function call, get through a particular pipeline, and you would see what wonders Python can do. So as I said, we are going to do some mining. So the first thing I need is a mine, right? So what exactly does that mine look like? So this is an air quality data set that is available on Kaggle. The link to this is present at the end of this particular PDF. If you have already access to the PDF, you can go to the end of the PDF on the last slide, and I have given the actual Kaggle URL for this, right? Or you can just go on the internet and just search for this. There are many air quality data sets that are available, by the way, on Kaggle. One of the good things with this data set, which actually got my attention, was this very high usability score, right? It meant that this data set has very few missing values. Most of the things that are shared as part of the data set is not junk. It's actual data, and people, you can see this code part, right? People have written some code and they have tried to figure out different things out of it. We have also written some very basic code. The code that we will see here is certainly by no means it is of high quality, right? This is just a code to get you started. But the reason I am sharing all this code with you is that you can make very small changes, and in fact, I will show you where to make those changes in the code as well, and then you can start your own experimentation in this field, right? So this is the mine that we are going to look at, and then these are our shovels, right? So shovels, you understand, I'm just grinding this analogy to death, that if there is a mine, you also need the shovel in order to get things out. So there are these 4 or 5 things that we are going to use. The first one is pandas. So for those of you who have been a regular in Python, I don't think you would need any explanation about pandas, right? But for those of you who are new to Python, just consider that one of the basic features that pandas give you is that you can kind of put all your data in an in-memory data structure, which is also known as a data frame, and it's very efficient, right? I mean, you can consider this to be a kind of an array, right? It's a two-dimensional array where you can fill up data, and then this so-called array can be easily thrown from one function to the other function, right? So pandas is a very powerful data analysis and manipulation library in Python. And if you have ever done any kind of machine learning in Python, you would probably be aware what pandas can do. Then NumPy is the core numerical computational library in Python. This particular library, with the help of this, you can do almost all kind of statistical analysis that are there. So essentially, you can say that NumPy can be considered as, let us say, the Fortran equivalent in Python, right? So whatever people used to do in Fortran, NumPy can also do that for you. In fact, if you have done any courses in machine learning before, you would know that a lot of probability, a lot of linear algebra is often involved in any tasks that are associated with AI, right? So all these can be done easily with the help of NumPy. Then scikit-learn is essentially the primary library for machine learning in Python. Keep this in mind, we are not going to use any kind of funky machine learning today, right? For example, neural networks. We are not going in that direction. We are just doing some very basic analysis today. So scikit-learn is not something that people use for neural networks. They might use it for dataset management, but then you have other libraries like PyTorch, which people use for neural networks. So, but scikit-learn is a very nice library, a very simple, clean library to manage your data sets. We will also use these two guys, matplotlib and Seaborn. These two are kind of the guys. I mean, again, if you have been just working in machine learning, maybe you would not have used these. But this is something which is specific, for example, to a data analytics or a data mining course, because it is not always about just finding correlations. Many a times, you also need to visualize how the data looks like. So these two guys are going to help us with that data visualization. So let us start with the first thing. In fact, if you guys want, you can also run the code that is given there. But this is the part of code which is basically going to create some visualization. So what we are going here in this, and by the way, there are scripts that are available in that particular folder, and we are giving away all the code and the data. The data set you can anyhow download from Kaggle, but these scripts are available as part of the folder that we have shared. So the first script that we are looking at, it provides a very basic thing. It essentially says information about the missing values, basic statistics about this particular data set, and then two simple plots, right? So this is one of the plot that was created. In fact, I can probably show this. I don't know whether my screen will be visible to you. Is my terminal visible to everyone?
Yes, sir, it is visible. And
Okay,
students can post in the chat also. Is it visible?
I guess yes. Okay.
Yes. Okay.
So a very basic thing that I would show you, right? I mean, of course, the rest I will probably not. Okay, I need to provide it the data set, right? So this is what MATLAB, this matplotlib can do for you, right? This is basically a plot of the distribution of PM 2.5. There are some tools available for you here, right? And again, I have not written any specific code for it. Don't think that I have created, I'll, in fact, the amount of code that I have shown you, this is precisely what it is, right? Nothing more than this. This is the amount of code that has generated this, and then it gives you the option to just zoom in on a particular part of this code, right? You can keep on zooming in on a particular part of this code. You can select certain, there are sliders that can somehow tell you that what should be the size of of different aspects of this particular graph. And then of course, if you click on home, you revert back, right? Then if you close this, I have another box plot. So a box plot, I'm pretty sure the last plot must have made quite easy sense to you. A box plot can be considered as a place, and you can see what this box plot essentially tells you. It is easy to figure out that this part is basically, this is the meaty part of your data set, right? That most of the values are essentially lying in these regions, right? But then you also have these guys, and in fact these guys can probably be considered, the ones on the top. In fact, let me just do it like this. So these guys on the top can be considered to be the outliers. So many a times in a particular data set, you will find outliers also, and outliers are going to create a lot of problems, because any models that you are going to build over them, it is these guys who can make these models go really bad. Okay, they are the ones who kill your accuracies, and yeah, they introduce a lot of bias. So this was just a basic example. In fact, on the terminal, you can see what exactly it has produced. It will tell you the missing values for different columns. I don't know how it got such high usability rankings. Maybe there are people who are friends of the author who has made this highly usable. Anyhow, but there are so many values that are missing here, and then there are these things like mean, standard deviation, things like this, right? So what exactly was this? This is just an example of visualizing the data, right? The second thing that we can do is what is known as feature engineering. So in one of the case, in what we are doing here as part of feature engineering is that we are adding more features. It is not necessary that you add features. Many a times you might actually remove features as well. So for example, one thing that we are doing is we are adding two of these features here: 3-day rolling average of some particular value that is already there, and then a day over day difference. So basically you try to take differences between, let us say, row n and row n plus 1, right? And if you produce the output, this is what it looks like, right? The first 10 rows, and now you have these newly added columns to this. In fact, this column, we are, by the way, nan is something, if you are new to this word nan essentially means not a number, right? And unfortunately, as I would call it unfortunately, many a times when you will actually run into real world data sets, you are going to see these nans, okay? Because it means this particular place you expected this to be a number, but somehow because of certain reasons it is not really a number, and then that is what is known as nan. Then classification and regression, well, this is something that I guess most of the people today who have done some kind of machine learning are already aware of. So classification is the process where you try to classify a given data into certain number of classes. So here you can see that the idea that we are trying to do is we are just trying to classify the air quality as good, moderate, or poor, and we are using a particular approach called logistic regression. Logistic regression is one particular type of classification model. There are many others. If you have already dived into the neural network world, then you might find these kind of models to be too archaic. But yes, there are models like these which are still being used. As I said, in many cases you don't really have a very complex data to fit. So why just go for neural networks? You can use something very simple, right? And of course, you can see that the classification accuracy that I was getting was only 0.71. I can run all this code as well. It is there in the same folder. Um, and of course, 71% might be a little too poor from today's perspective. We are now living in the era of neural networks where anything below 95% just does not cut it, right? And that is why I said, I'm quite weak at mathematics. You guys might be better at this, and so you can probably come up with a neural network solution for this. And then of course this is the last part of this code where we are trying to do a regression. So as I said, regression is just the first cousin of classification. In classification, we tried to predict whether the air quality was good, poor, or bad. And here we are now trying to guess an actual AQI value, right? And the whole process of guessing a value, in many cases, the amount of errors that you would see would be much higher. In fact, there are certain errors, and just like a typical Ekta Kapoor serial, I'm just going to leave you hanging here to figure out what these are. But I'll just give you a hint. This is a very large error value, by the way. But a mean squared error essentially means that you were trying to predict something and then you predict something else, you find out the difference, and then you square it, right? I'm not going to go into much details. I'll just leave this here with me. I think I've already run out of time. I need to hand it back to Shruti. So just to wrap it up, by the way, what you can do from here is you can go through the code that I have shared. There is some data that is already there. I mean, in fact, if you want, you can directly download it from Kaggle. But in that particular folder also, this whole data set is already present. And of course, there are, and by the way, the resource, I have seen some of the chats. They are saying that the password is not working. I'm not really sure what exactly happened because I was just trying it right before the session and it all worked fine. There are some good online magazines where you can go through. So I have put the link to one of them here, and of course you can enroll yourself in these courses on artificial intelligence and data science. In many cases, the kind of skill set that you require for, let us say, machine learning, artificial intelligence, data analytics, data mining, there's going to be a lot of overlap in the tools. And for example, Python is going to be your savior almost all the time. You are going to go through many libraries, where you will be, for example, pandas and numpy and scikit. All these are going to be used in for probably all the courses that you are going to do, right? So here, I mean, I think this is it from my end, and I would actually now like to hand over the podium to Shruti again. Back to you, Shruti.
It's really our pleasure that you have come on this platform. And the way you are have been taking this session, the masterclass is really indeed a true masterclass. Now it's time to take a quiz question. So there is one quiz question. It's like it will not come on a poll. It's kind of match the following. So if your answer is A from this side and two from this side, so you can post in the chat A2, B5 or B1, C3, like this you can post it. You will able to see the question in the PPT also here that match the following: classification, regression, data visualization, and feature engineering. These are the this side columns. And here you can select that A is matching to which one, then you can write the number there. Suppose A3. And B is matching to which one, you can write the number with B. Suppose B2, like this. So this is the way you can explain. Till then, sir, I have, there is a few questions from the students also.
Yeah.
I just wanted to take one question which Dipali just asked. What is the difference between data analyst and business analyst?
Analysis or analyst, like whether you're talking about the verb
Analysis.
or the noun.
She is asking for analysis. What is the difference between
Analysis.
data analysis or business analysis?
So I would
Basically,
say, see, you can do business analysis without data also if you have that kind of hunch, right? If you are that good at your business, maybe I'm not a business guy, so I'm probably not the best person to tell you what is business analysis. But yes, you can see that business analysis essentially means you are trying to take up business decisions, right? These business decisions may be data driven or may not be data driven, right? It can be, for example, as I said, it could be a simple hunch. You can say that the market is going to go down in the next 3 days, so let us buy the stocks today, right? I mean, this is just a hunch. Or it could be an analysis which is driven by data analysis. You can kind of look at the world scenario. You can create a model which feeds on the news items from throughout the world. You realize that there has been, Donald Trump has taken over US, and then he's planning to put some tariffs on India. So maybe in the next 3 or 4 days, the stock exchange is going to go down, right? So this is essentially a kind of a data-driven analysis, right? So business analysis, you can say that they are two different things, but yes, there is a kind of a common path. Data analysis can be done for different ideas, right? You might want to do data analysis for figuring out whether this particular course is going to be beneficial for you or not, or whether, and I'm pretty sure this is something that all the students do. What is the chances that I'll get a good grade in this particular course based on the feedback by the previous year's grades, right? So data analysis can be applied into multiple fields, and business analysis, as I said, it can be something that is specific to your particular business domain. You may or may not use data for it, but the whole point of this uh, this program is that unless you are very good and very lucky, the chances that your business decisions will be right without actually looking at the data, they are very slim, right? So in most cases, unless you are making a data driven informed decision, most probably your business analysis, again, as I said, I'm not really a business guy, so probably not the best person to make a call on this. There might be other people in this chat who may be more apt for answering this. But yeah, this is the overall idea.
Thank you so much, sir. I hope, Dipali, you will get your answer. So now I request my team, please show the correct answers. Great. So A is basically fourth one, B is third, C is first, and D is second. I hope you all students get most probably correct answer. And in fact, I saw the last two students, Augustine and Vivek, most probably they are near about correct, just in two cases they just interchanged. But still fine. So many students are near about it. Nice. So, sir, next question is from the Swati, and she's asking that Matplotlib is in the Python, and if we are using a Power BI, still it is we can use there also. But if we are doing a data mining, still we can use the in the Power BI also data mining, or it is only for visualization.
So you have to understand that what exactly this so-called plotting library does, right? At the core, the job is that I have some data and I need to visualize it, right? I mean, I just gave you Matplotlib as one particular example. I'm pretty sure there might be other libraries that are out there which could be used for the same purpose, right? The idea is whether it is Power BI, whether it is even basic Excel, you can create graphs in Excel also. Power BI is probably, far ahead. You can create simple graphs in even Excel today, right? The idea that I wanted to give out was that you need to find out these tools based on your particular skill set. So, for example, if you are not a Python guy, if you are a Java guy, for example, right, there are plotting libraries in Java, right? You have to somehow figure out how to give your data to that library and create a plot, right? Similarly, I'm not really a Power BI guy. I'm not really an Excel guy. I'm an academician. I don't pay money, right? I just use free things, and Python is free. So basically, the solutions that you would see from me will probably be these free and open source solutions. But yes, this particular example, I just said that uh, the idea is not really to focus more on that particular library. The idea is to focus on that particular concept. That before starting off with any kind of AI, data science, machine learning related activities, um, many a times people actually miss this part. That maybe I'm trying to use a sword for something where a needle can do the trick, right? I mean, if the data is a very good, as I said, it's a bell-shaped curved data, right? Probably I don't need a neural network here in order to fit a curve to this, right? We can very easily try to just build a simple estimation curve where I just say mean and standard deviation, and all I need to do is find out what is mu and sigma, right? And I can just try to fit the data to this. So this was the idea. Just use any plotting tools. It's not necessary that you use Matplotlib. Use any particular libraries that are available in that particular programming language or that particular environment where you are comfortable with. I'm pretty sure plotting is a very basic thing. You can find n number of tools that can do that for you.
I would like to ask you another question. The student is asking, Python programming is also needed for data analyst, or I should not require to learn Python libraries. I should know Python libraries or not.
Um, Okay, so that's like saying that can I do trading on the stock exchange without actually knowing how trading works, right? I mean, yes, you can. You can certainly you go and click on the internet on certain buttons, and of course you will end up buying and selling something. Uh, but and I'm not saying that you will always be in the loss. You know, sometimes you will also make a profit out of it. But yes, the difference between doing something properly versus doing something on the hunch, the same thing is going to be here. If you are going to remain in this free and open source world, right? As I said, there are paid solutions for this. Power BI is a very good example of it, right? And Power BI is actually quite good at it as well, right? But the point is, if you are, is as I said, if you are just a person like me who are in academics and who doesn't really want to pay, and specifically for students, this is going to be an extremely important thing, right? If you go and talk to your father and say that I want to learn Power BI, just buy a license for Power BI for me, right? It's going to be a little difficult. I'm not saying Power BI is bad, right? But the point is, in many cases, if you learn basic Python, and today you don't even need to learn a lot because we have things like Chat GPT, right? as long as you understand what you want and as long as you can type it in a chat GPT prompt, right? Chat GPT will probably be able to give you full piece of code that you can simply copy and paste. And and chat GPT will even suggest you. In fact, I asked chat GPT what is the best library for plotting in Python today. And the chat GPT suggested me that you should use matplotlib, right? So I'm not an exception. You can also use any of these modern day LLMs. And knowing Python coding in depth, and I'm not a Python coder, by the way. I'm from a previous generation. I'm a Java coder, right? But still, I had to make this transition. I write basic Python code with the help of let us say Chat GPT and get my things done. And this is all you have to do, right? You have to understand the concepts, and then as time will come up, right, you will realize that the task of actually writing the code is going to become a menial activity, right? There are going to be AI bots all over around you, but as long as you know how to direct them, you will be able to write the code, right? So I guess the answer would be you really do not need to learn Python, but it's strongly recommended that you go in that direction if you want to pursue a career in this field.
Great. So, sir, few students are asking, is there any coupon code? Yes, we announced the coupon code. I request my team, please post the coupon code again. And one of the students is asking that I'm not from the IT background, so even I don't know about the Python or Java also. So it appears difficult for me to learn.
See, in many cases, you will understand that programming is not something that is too difficult, right? Programming, as I said, especially if you have something like Chat GPT at your disposal, it's all about logic, right? And as I gave you a very simple example, I'm not a Python coder, right? But I'm able to live in this ecosystem because at the end of the day, I just have to understand what is to be done, right? If I can somehow plan a pipeline that, right, this is the first step. I have to visualize the data. After visualizing the data, I understand this is the kind of models that I need to fit. Maybe I should do some kind of feature engineering to make sure that the junk, the noise from this data set can be removed and only the substance remains, right? As long as you can think like this, as I said, right? Today, it's Python is something that is too simple to do, right? I mean, you don't even have to, as I said, you don't even have to understand. I showed you so much code, right? And it was like 5 lines of code, and it created a plot, and you can zoom in, you can zoom out, you can go back, you can go front. I just wrote 5 lines of code, right? And that 5 lines of code can simply come from Chat GPT. You don't even need to write that, right? So in many cases, I would say even if you are not from the IT background, just install a basic Python compiler on your machine, and there is enough help available online that you don't really need to understand Python at depth, right? In many cases, all you need to know is how to execute a piece of Python code, right? You just copy it, paste it at some place, and then there is like a command. And you don't even need commands these days. There are notebooks that are available. So you just, it's like clicking in a browser. So, yes, would you be benefited if you have a Python background? Yes, no, I can never say no to that. If you are a inherent Python coder, you will be able to pick up things much faster. But saying that not knowing Python is like a boulder that you have to cross, I won't say this, right? I mean, maybe you'll have to spend a few more weeks figuring out how Python works. But as I said, you don't have to go into the depth of Python to do all these things.
Great, great. So basically, if we wanted to do a data mining on a vast amount of data, suppose like Excel will not able to take this much data. So definitely we need a Python to do the data mining on that particular data. So it is a basic requirement for data analytic person. So definitely it is also required. If you know Excel, again the sir is saying correct that if you know Excel, okay, trading you can okay buy, you can do that things. But if you know Python better, so it's great. You actually do the trading in a depth. Okay, that's great, sir. Nice explanation. So I would like to request my team, please share the link of the sir all data, whatever the data shared by the sir today, and show the code, everything. Please share that link with the password. And students, might be possible that you are using a space of something in the password. So try to remove that space. Only this is hyphens are there. TCS hyphen iON hyphen IIT ISM. So use only this one. Don't put any space anywhere, even not before TCS and not after M. That is ISM. So
So
hope
what I'll
that
do is
link will work.
I'll just shorten the link as well, so maybe that will work. I'll just put it to all panelists. I'll just make it everyone. This is the shortened link, right? So
Great, great. So now the students can access very easily. So you just take that short link and after that put this password. And sir, the one of the student is asking, is it case sensitive? The password. Yes. So it
yes,
is
the
a case
password is case
sensitive.
sensitive.
Definitely, most probably everybody, even your email ID password is also case sensitive. So whenever you ask for the password, generally it is case sensitive. So with this, we come to the end of the session. And thank you so much for this wonderful session. So with this, now I would like to thank to my audience also. You can always reach to us also for any queries. I request my team to share the email ID. For any queries, you can reach to this email ID. I want to especially thank you, sir. It's been a pleasure to be here in your masterclass. And the way you explained, the way that you summarized everything, it was really awesome. And I urge you, all of your students, that if you buy this course before 16 Feb, you will get a special discount of 10%. And Saurabh sir, would you like to add something?
Nothing from my end. I think we have already covered everything. And as I said, many a times people might feel that this activity requires a lot of technical background. But now we live in the era of AI, right? And AI can help us in learning other forms of AI, right? This is a very good example that you don't really need to go into the depths of for something like Python. As long as you understand the concepts, that, you should be fine.
Absolutely, absolutely. These days, if you will ask any question from the AI, you will get an answer very quickly and very relevant answer. That even if we are talking about a code also, so like you were told that library is suggested by the AI. So that is really true. They actually provide a relevant things and exactly which is required at this moment. So I would like to, with this, I would like to thank you, my audience, also for your active participation, and thank you once again for your time and presence. So me and speaker signing off today, and have a pleasant evening. Thank you.
Bye, 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 everyone.
Bye.